Okay, ladies and gentlemen, we were talking in our past lesson on the quadratic formula and how many solutions there are. So we're going to extend that now to look at complex numbers. So what we're going to do is we're going to look at the equation at y equals x squared minus 4x plus 3. And what we're going to do is graph the equation and identify the x-intercepts. So what I'm going to do is I'm going to make a table. There's an x and y. And I'm just going to pick some convenient numbers. I'm going to pick -2, -1, 0, 1, and 2. And I'm going to substitute those numbers into the equation to figure out the y values. And then I'm going to graph those. So in doing that, I'm going to substitute -2. I'm going to put that in parentheses because the square -2. That means -2 times -2. If you don't, it will go 2 squared and then take the opposite. So -2 squared minus 4 times -2 and then plus 3. And I got 15. That's going to be off the graph. So now I'm going to plug in -1. A shortcut, if you hit second and then entry, we can go back and over our -2, put in 1, and then hit enter, and I got 8. If I substitute in 0, again, second entry, and I want to get rid of the negative, so I can press delete and then hit 0. And then here, again, delete and 0. And I got 3. And then if I substitute in 1, I got 0. And then substituting in 2, I get -1. And then I'm going to keep going. So 3, 4, and 5. So when I put in 3, I got 0. And I got 3. So it looks like 1, 0 is my vertex. So I'm going to go over 1 and then, oh, I misspoke. I'm sorry. The graph goes lower. So 2, -1. So over 2, down 1. That appears to be my vertex. And then if I go to the left to 1, I go up to 0. And then if I go right over to 3, I'm at 0. And then if I go here to 0, I go up to 3. And then the same thing over here at 4, I'm also at 3. That's enough information to graph my parabola. My x-intercepts are x equals 1 and x equals 3. Now to solve this with the quadratic equation, I identify a, b, and c. So this is 1x squared. So I know that a equals 1. B is -4 and c is 3. So in just writing the quadratic formula, to remind you, we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to substitute in my numbers. So negative b, so the opposite of b, or negative of -4 is going to be 4, plus or minus -4 squared. I know that that's going to be 16. And then minus 4 times 1 times 3. And then on the bottom, I have 2 times 1, or 2a, which is just 2. Now I can actually multiply that out. 4 times 1 times 3 is 12. And 16 minus 12 is 4. So this is going to simplify into 4 plus or minus the square root of 4 over 2. I can simplify that further because the square root of 4 is 2. So this is going to be 4 plus or minus 2 over 2 for x. And now I'm going to break that up into two solutions. X is going to equal 4 plus 2 over 2. And simplifying that, 4 plus 2 is 6 over 2, which is 3. Which, again, we can see that x equals 3, and I'll box it in. And then my other one, x equals 4 minus 2 over 2. And 4 minus 2 is 2 over 2, which is 1. So we get x equals 1. So again, those match those. So our solutions, the solutions are the same. So if I need to graph this equation, what I'm going to do is actually use technology to help me out. So in graphing this, I can actually press y equals and then type in x squared plus 4x and then plus 4 and then delete out anything else. Oops. So now if I want my table, I can go back here and then I'll look for ones in the graph. I notice if x equals -4, that's over here. I go up to 4, so 1, 2, 3, 4, and then I put a big dot. When x is -3, I'm at 1, so -3 to 1. When x is at -2, I'm at 0. When x is at -1, I go up to 1. And then we know that parabolas are going to be symmetrical. So we can see that this graph has one x-intercept at x equals -2. Now to solve this with the quadratic equation, again, identifying a, b, and c, a equals 1, b equals 4, and c equals 4. So to put that in now, we know that x equals the opposite of 4, so -4, plus or minus the square root of 4 squared, 4 times 4 is 16, minus 4 times 1 times 4. Well, that's going to give me 16. So in the numerator, this is going to be -4 plus 16 minus 16 is going to be plus or minus the square root of 0. And then all over 2 times a, or just 2. Well, if I look at that, the square root of 0 is 0, so I'm adding and subtracting 0. That doesn't give me anything. So x is going to equal -4 over 2, which gives me 2. So the solutions, -4 over 2 should be -2. Thank you. Made a small mistake. And the solutions relate to part A. They're the same. So we have here, let me just show this a little bit better. X equals -2 here, and x equals -2 there. So the solutions are the same. So to relate that as to y, if I were to take the standard form of the equation and try to factor it, pretty much everyone in class does the area model. So if we have x squared and 4, and we need to break up 4x and 4, we have to have 2x and 2x. So this would factor to x and 2 and x and 2. So this in factored form is y equals x plus 2 squared. So the zeros of x plus 2 squared is just going to give me -2. So to solve that, we would say, well, x plus 2 equals 0 or x equals -2. So we can see that Because it was a perfect square, it only had 1 0. So now we're going to graph this equation. Y equals x squared minus 4x plus 6. So first, I'm just going to look at the equation on my graphing calculator. And when I graph it, I notice it doesn't touch the x-axis. So we know that there's going to be no solutions. But the plot thickens. It's actually going to be there's no real solutions. So to get this graph, I'm actually going to go to the table. And I notice that at 0, we're at 6. That's going to be on the graph. At 1, you're at 1, 2, 3. That's on the graph. At x equals 2, y is 3. So 1. Oh, x equals 2, it's at 2. Sorry, I misspoke. So right there. And then at x equals 3, you're at 3. And then the graph becomes symmetrical. So on here, that graph the x-intercepts, there are none. So I'm going to write none. Now, in looking at the quadratic formula, again, a equals 1, b equals -4, and c equals 6. And then on here, so x equals -b, so x equals 4, the opposite of -4 is 4, plus or minus the square root of -4 squared is 16, and then minus 4 times 1 times 6, all over 2 times a, so all over 2. So this is going to equal 4 over 2. And then this is going to be 16 minus 24. So plus or minus the square root of 16 minus 24 is -8. And then what we said here, the square root of -8, you can't do it. So this is not possible. There's an error. So there are no, we'll put real solutions. So how do the solutions in part A and part B relate? We found no real solutions. So in looking at the back, we'll actually look at something. Before the 1500s, mathematicians could not solve equations like the one in number 3 with the square root of a negative number. So thus, Leonhard Euler introduced the symbol, the square root, introduced the symbol I to represent the square root of -1. So rewrite your answer from part 3, taking the negative square root out and putting the I before the square root. We're actually going to put the I after it. So if we have the square root of -8, what we're going to do is say that that really equals, if I break it up into the parts, the square root of -1 times the square root of 8. Square root of -1 equals I times the square root of 8. And then we would really write that as just 8I. So what I do is when we have the square root of a negative, I just take the I out and put it at the end. So as an example, if we had the square root of -23, I would just know that we have to lose the I to the end and call that the square root of 23I. So math is fun until someone loses an I. Okay, so ladies and gentlemen, if we talk about that, real solutions show up on graphs as zeros, or we also call those x-intercepts. So I'm just going to write x, I, and t for the intercepts. If there are no real solutions, the graph doesn't touch the x-axis. So we find the non-real imaginary solutions by using the symbol I in place of the square root of -1. So these solutions will always show up as, these are called complex conjugates. Or you can just call these complex numbers. Either is fine. And they'll always be of the form a plus bi and a minus bi. So now we're going to find the solutions and draw the appropriate graph without using your calculator. So what we're going to do is say that A equals 2, B equals -3, and C equals 4. Now, in order to do this, we're going to look at the discriminant. And the discriminant is b squared minus 4ac. And we're going to look at that square root, because if this is going to give us an imaginary number, we know that that is going to be negative. So b squared, -3 squared, is going to be the square root of 9 minus 4 times 2 times 4. So 4 times 2 is 8, and 8 times 4 is 32. So we just need to do 9 minus 32, which gives us the square root of -23. So we can just drop the I, and that gives us the square root of 23i. So now if we were to put that out into the quadratic formula, x equals the opposite of b, so 3 plus or minus the square root of 23i, and then over 2. Now we're going to break it up into that a plus bi form. So to do that, we have to break up the fraction. So we're going to write 3 over 2 first. So x equals 3 over 2 plus or minus, and then we're going to have the square root of 23 over 2. And then we write our I. So now to go further, we know that our two imaginary solutions are x equals 3 over 2 plus the square root of 23 over 2i, and then also x equals 3 over 2 minus the square root of 23 over 2i. So if we look at that, in looking at the connections to the graph, if I calculated the minimum there, we can see that the vertex coordinate is 0.75, and then the y coordinate of the vertex is 2.875. So in looking at that graph and just sketching it, we'll actually use our calculator. It looks like this. So in looking at our second problem now, we have, let me break this up a little bit further. So we have x squared, and I'm going to put plus 0x and then plus 3 equals 0. So now we know a is 1, b is 0, and c is 3. I do that to be explicit about the value of b. So in looking at our discriminant now, we need to do the square root of b squared minus 4ac. So 0 squared minus 4 times 1 times 0. Or 4 times, I'm sorry, c is not 0, it's actually 3. So let me put 3 in there My apologies. So again, that's minus 4 times 1 times 3. So it's going to be the square root of 0 minus 12 is going to give us the square root of negative 12. So now we lose our I, and you get the square root of 12I. So now in doing this, x equals the opposite of 0. So we have 0 plus or minus the square root of 12I, and then divided by 2 times a, or 2 times 1 is just 2. We can drop this 0 piece, and we have x is equal to the square root of 12 over 2I, and again, that's plus or minus. So we have two answers. X equals the positive square root of 12 over 2I, and x equals the negative square root of 12 over 2I. And then further, I know that 12 is a product of a perfect square. Our perfect squares, again, are 1, 4, 9, 16. And 12 is written as 4 times 3. So if I were to simplify that, x is going to be written as the square root of 12. We can say the square root of 4 times the square root of 3 over 2I, or x equals the square root of 4, the negative square root of 4 times the square root of 3I over 2. The square root of 4 is 2, so this is 2 over 2 times the square root of 3I, which that's going to cancel out. We're going to get x equals the square root of 3I. And then here, this is going to be x equals the negative square root of 2 times the square root of 3I over, or the square root of 4, I'm sorry, is negative 2 over 2. That's going to reduce. So we're going to get x equals the negative square root of 3I. In looking at our last problem, we need to add 5 to both sides. So we get x squared plus x plus 5 equals 0. Or we know that a equals 1, b equals 1, and c equals 5. So in doing our discriminant, b squared, so you'd have 1 squared minus 4 times 1 times 5. So it's going to be 1 minus 20. So it's going to be the square root of negative 19, which is the square root of 19i. And then what we're going to do is break that up with the Pythagorean theorem. So x equals negative b, or negative 1, plus or minus the square root of 19i, and then all over 2a, or 2 times 1, so over 2. And then we're going to break that up again. So x equals negative 1 over 2, plus or minus the square root of 19 over 2i. And then we can break those up into the plus or minus pieces. So x equals negative 1 over 2 plus the square root of 19 over 2i. And x equals negative 1 over 2 minus the square root of 19 over 2i.